Alright everybody, I wanted to show off here the quick set bone transforms through the array function, right? So this is set up now, finally. Hope this is basically done. This is now actually basically doing a set bones by name, but through an array, right? So it's kind of like this one, the modify bone by name. You can input a bone. It's the exact same thing as, just the transform modify bone down here. So if you actually do, from pulling it in onto your animation graph, set bones transforms, there you go. So by default, it actually comes in with a bunch of data. You can expose more if you want. So you can actually see bone data is actually a struct. You can see here, I can actually show it. Right now it's actually showing that you have like what it's actually doing for your location, so translation, the rotation and space, but you can also expose the particular transform space. So instead of just this being a binding, this can be exposed as a pin, and that's what I did here. And what that's basically doing is you can see this has a whole bunch of options, but we'll get there in a second. For now, very much similar to transform modify bone, you have the availability of actually either setting it to be ignored on certain things or replace the existing or add to existing. So if you already had, prior to this bone that was inputted, then this bone would actually like add an offset or add existing, rotations or whatever on top of the thing that it already now knows for what it to be. So you can see here, if I have, multiple bone names, and I have the preview set up down here. Bone names, I have root and pitch. Here, actually, I'll show you real fast. The skeleton. So this is just the skeleton of the guy. There's the root bone. It's this little L thing right here. That's all skin to it. The pitch part, this box, and then the housing, this box is all associated to it, and the barrel. Cool. So all that said and done, what this is doing, just to briefly explain, it's whatever the bone name, is, it takes that as the index for what they need to be, and then so like if this is index 0, it will try to modify this transform of this same index, right? So root will essentially have this. So on the root, now if I change the location, like on Z, you'll see here in the preview, if I actually modify that, ooh, look at that, up and down it goes. Or maybe I want to rotate or push it forward and back, or, left and right. Hey, that's pretty dope. And then same thing with rotation. Hey, that's pretty sweet. So what this is doing here is it's modifying, and as you can see here, the way that I have it set up currently, there's no inheriting the parent bone down the chain. So what this is doing is it's forcing like an offset regardless of the children being moved as well. So if we wanted to have that add on, then I can add that on. But for now, I think this works because you can see here now also for the pitch part, here I'll actually reset this to 0, 0, 0. For the pitch part, since I didn't actually define any bones underneath it, it will actually move the pitch part and all of its children. But if I added, for instance, here's another interesting bit with just for error correction. If you have mismatching number of arrays, so if the bone names has more or less, or if the bone transforms are more or less than the other one. So if bone names has more or less than transforms, or transforms has more or less than the other one, and they also don't match, right? So this needs to be called the right one. So this is matching to housing. This still won't move them because now we have to have a third index, and you can see as soon as I add the third index and the name also needs to match what bones it can actually find, then it can actually start working. So you can see here, anyway, going back to my earlier point, now that I'm actually adding the housing to this, since this is down the chain a little bit more, I can actually now move the pitch part independently, and then the housing itself, sorry, let me scroll down. the housing can now move that and the barrel as well, right? So yeah, these are all part of them, and these can all, and same thing with scale, you know, you can add, you can actually, well, actually you can see here, since I have scale mode ignore, right, rather than add existing. So if I change the scale to any one of these, it just ignores them, and it doesn't do anything. So that's one way to actually get around particular issues if you're wanting to say you want to ignore certain setups when you're actually going through the array. So yeah, with also, you can see here with replace existing instead. So you can see if I do replace existing, then what this is doing based on the particular transform space, it will replace the existing transform of that particular thing. So since we're considered in bone space, or sorry, component space, this component, the origin is right here. So that's why everything is moving to 0, 0, 0. So I can actually, you know, offset this now, maybe move, you know, the pitch part and maybe move it forward or whatever. And then same thing with the housing. I can move it up and now move it forward, right? But yeah, so this is a way to set them up so that you can have them do whatever. And then same thing with changing the particular transform space. So you have, for instance, you can inherit the parent bone space. So what this is doing is it's referencing back to the parent to see where it is and then trying to actually add the offset to it. So here, if I actually do 0, 0, 0 from that, you can see here, this is inheriting from this particular offset. So this is actually trying to move toward that parent bone space. So it's a little complicated. But if you go directly to bone space with 0, 0, 0, it just assumes where the original bone space is 0, 0, 0 relative to itself. So probably stick with bone space to make that easier for yourself to know, you know, just the offset from that bone space. And you can actually see the update here. If I apply this, compile this. Now you can actually see this actually updated on the individual, like this is an individual blueprint that's over here. If I, you know, change the location of the pitch part, and now when I apply this, excuse me, that default variable, I have to make sure that this recompiles, or you can do like a compile on update. And so by default, if you move them, then it recompiles it and you can actually see the new change there. So this actually shows now in relevance, you can see if instead of doing like bone space, you could do technically world space. I would not recommend doing this, but you can do it with this setup if you want, because it was available in the engine. And I was like, cool, all right, let's just make it an availability. So I turn it to world space, compile it. So in the preview, it will try to move everything to, you know, 0, 0, 0, but within this world in the preview. But in an actual level, if I move it down, oh shit, where'd they go? Oh, they moved actually to world space. So yeah, that's something that you can play with if you care about, you know, rotating and translating relative to world, you know, rather than, you know, component space. And if I compile this technically won't change, but now relative to the component, it should move back, you know, to there. So there you go. Now you see it, right? So yeah, that's pretty much it. You can play around with these as you wish, and I'll just show here you can actually do scale, so you can replace existing. I think all these are 1 to 1. Oh, that one is not. Let me change that. I'll go apply. So now if I wanted to, let's change, you know, this pitch part. I don't know, the scale of the top part. Why is that? Oh, there we go. Now it's working. There we go. Whee! So now I can stretch this or move this for scale as well. And this all updates in real time as well. Right now I just actually have them just tied into the bone transforms. So you can actually have some blueprint logic like piping this stuff in. But yeah, this is pretty much it. Have fun with this. And yeah, we'll see you in the next one. All right. Cheers. Oh yeah, I gotta apply that. There we go, and then compile, and then, whoo, there we go. Whoa, that looks all weird now. All right, thanks a lot for watching. We'll see you in the next one. Cheers.